Okay, let's take a look at 4.2, working with integer exponents. So it's good that you know the terminology first. The entire expression 2 to the power of 3 is called a power, where 2 is the base and 3 is the exponent. Okay, so this 2 to the power of 3 is a power, the 2 is the base, the 3 is the exponent. 2 to the power of 3 just means 2 times itself 3 times. So 2 times 2 times 2, that equals 8. So the rules for multiplying and dividing powers. It's very important you understand the expanded form of this. If we go to do 2 to the power of 2 times 2 to the power of 3, that is actually like 2 to the power of 2 is 2 times itself. Okay, so 2 times 2. And then times 2 to the power of 3 is 2 times itself 3 times. So you end up with 2 times 2 times 2 times 2 times 2, 5 of them. Okay, so 5 of them in exponential 4 is 2 to the power of 5. So we have to have a rule to go from here to here. Well, when you have bases that are the exact same, you keep the rule is, and you're multiplying them together, you keep the base the same and you add the exponent. And then of course 2 to the power of 5 is 2 times itself 5 times, which is 32. Okay? And then if we look at the division, we have 10 to the power of 5 divided by 10 to the power of 3. So if we write that like this, 10 to the power of 5 is 10 times itself 5 times. So 10 times 10 times 10 times another 10. And if we divide by 10 to the power of 3, on the bottom it's going to be 10 times 10 times 10. That's 10 to the power of 3. And then just like we did factors in Unit 2, we can cancel out factors. 10 divided by 10 is gone. This 10 divided by that 10 is gone. This 10 divided by that 10 is gone. So all that's left is 10 times itself. So that's 10 to the power of 2, or 10 squared. So there is a rule for division of how to go straight from there to there. The rule is if you are dividing two powers that have the exact same base, only when they have the same base, you keep the base the same and you subtract the exponents in that order. And then 10 squared is obviously 10 times itself, which is 100. So conclusions: when multiplying powers with the same base, you add the exponents, okay? And then when dividing powers with the same base, you subtract the exponents. And always keep the base the same. So notice that the base stayed as 2. It didn't become 4 or something because 2 times 2 is 4. Again, the rule is keep the base the same, add the exponents. So this can only be used, dividing and multiplying rule can only be used when you have the same base. If you do not have the same base, there is no rule to doing that problem. You must have the same base, and it must be multiplication, keep the base the same, add the exponents, division, keep the base the same, and subtract the exponents in order. And so let's take a look at example 1. It says expresses a single power, so 3 to the power of 7 times 3 to the power of 5. Those two powers have the exact same base. The base is 3. So the rule for this is keep the base the same, add the exponents. 7 plus 5 is 12. So this is the final answer. I'm not going to actually do 3 to the power of 12 because it's too big of a number, so I'll leave it like that. And then over here we have 9 to the power of 6 divided by 9 to the power of 4. Again, the rule is for division, if the bases are the same, keep the base the same, keep it as 9, and subtract the exponents in order. So 6 minus 4 is 2. And this is the final answer. Of course, if you wrote 81, that's perfectly fine. Not too big. And let's take a look at powers of powers. So let's take a look at this table and come up with a rule for powers of powers. So this says 7 to the power of 5 all cubed. So what does that mean? Well, if something is cubed, it doesn't matter what we have cubed. Let's say, for instance, we had a symbol like star cubed. All that would mean is star times star times star. And so likewise, 7 to the power of 5 all cubed means 7 to the power of 5 times another 7 to the power of 5 times another 7 to the power of 5. And we know how to do this question here, 7 to the power of 5 times 7 to the power of 5 times 7 to the power of 5. That is a multiplication rule. Those bases are all 7s, so in that case you keep the base as a 7, and you add the exponents. 5 plus 5 plus 5 is 15. So the final answer is 7 to the power of 15. Now we have to come up with a way of going from there to there. Now notice that this is called a power of a power because you have 7 to the power of 5 all to the power of 3. There is only one base here, it's 7, but there's two powers, so it's to the power of another power. When you have this, what you want to do is, the rule is, keep the base the exact same except you multiply the exponents. 5 times 3 is 15. So that's how I go straight from there to there. Okay, so conclusion. When raising a power to a power, multiply the exponents and always keep the base the same. Okay, so if we do example 2 here, if you take a look here, this is 4 squared all to the power of 8. So we have a power of a power rule here again. So what we're going to do here is, the rule is keep the base as 4, and power of a power means we multiply the two exponents with each other, so 2 times 8 is 16. So we'll keep this as 4 to the power of 16. I will not simplify that any further because it's too big of a number, so I'll leave it that way. This one here, question B, this is y all squared to the power of 4. So it's y to the power of 2 all to the power of 4. Again, this is a power of a power, so we're going to keep the base the same, that's the rule, and multiply the exponents with one another. 2 times 4 is 8. And so this final answer will be y to the power of 8. So far you've learned two rules. You have the multiplication / division rule, in which you keep the base the same and add or subtract the exponents. And then you have a power of a power rule, which you keep the base the same but you multiply the exponents with one another. If we turn the page, I just provided you with a summary here for exponent rules. So rule number 1 was your multiplication rule, so you can read that over. Rule number 2 is your division rule, you can read that over. And here's rule number 3, which we just did, power of a power. Now let's take a look at the zero exponent. So if you take your calculator out right now and you just plug in 2 to the power of 0, that will equal 1. And 3 to the power of 0 equal 1. 10 to the power of 0 equal 1. Well, why does anything to the power of 0 equal 1? And so that's what this example here is meant to explain. We take a look at this example, but we're going to do it twice. Okay, so the first time we do it, 2 cubed divided by itself. So 2 cubed divided by 2 cubed. If we did this not using exponent rules but using simple math that we know that 2 cubed is 2 times itself 3 times, so 2 times 2 times 2 is 8 on the top. Well, obviously on the bottom, 2 cubed is also 8. 8 divided by 8 is 1. Okay, so we haven't done anything wrong there. 2 cubed divided by itself is 1. However, if we try to apply our exponent rules, which is what we learned today, our division rule states that if we have two exponents, or two powers, that have the exact same base, and we're dividing them, we're going to keep the base the same and subtract the exponents. Well, 2 cubed divided by 2 cubed, the rule is keep the base as 2, subtract the exponents. 3 minus 3 is 0. So you end up with 2 to the power of 0. So you haven't done anything wrong here either according to your exponent rules. Well, if you've done this question two different ways, one using simple math and the other using exponent rules, what this means ultimately, this is the final answer. But over here, this is also the final answer. So that means these two things have to be equivalent. 2 to the power of 0 has to be the exact same as 1. And the same rule can be applied for any base. And that's why I wrote here any base to the power of 0 is equal to 1. The last thing we're going to learn about is negative exponents. So negative exponents, if you take a look at, I'm going to show you the exact same problem except twice again. The problem is 2 squared divided by 2 to the power of 5. So the first way we're going to do it is we're going to do it using simple math again. So simple math states that 2 squared on the top just means 2 times itself. And 2 to the power of 5 on the bottom means 2 times 2 times 2 times 2 times 2. 5 times. And then obviously if we simplify this, remember these are all factors. This 2 divided by that 2 is gone. This 2 divided by that 2 is gone. So 2 divided by 2 is just 1, 2 divided by 2 is just 1. So at the top, all you're left with is not 0, but 1. And on the bottom, you're left with 3 2's being multiplied by each other. So you're left with 2 to the power of 3. So if you do it just using simple math, you end up with 1 over 2 cubed. Makes sense, because if you take a look at this, there are 3 more 2's on the bottom than there are on the top. So this is why you end up with 1 over 2 cubed. However, if we do this same exact problem using exponential rules, the rules state that if you're dividing two exponents or two powers that have the exact same base, you're going to keep the base the same and subtract the exponent. So I have 2 to the power of 2 divided by 2 to the power of 5.